Hi guys, so let us go and look at this example where they gave us two expressions of the trig ratio between certain angles, and then they say determine the following without the use of a calculator, this compound angle. So with this, they want this, right? So we know that with our compound formulas, we just have to see, okay, this form is related to which formula. We can see that it's related to this because it's sine A minus B. So now, yeah, be careful. We can see here that it says A minus B. Yeah, we are saying B minus A. So in a sense, their A is our B and their B is our A. Order matters. Order matters. Unless if you want to make the situation much more bearable, you can just say sine A minus B but negative over there, just so that we can just write it as is without confusing that A is B, B is A, yada yada. So now this is a negative angle. It's a look at this as one angle. The A minus B is one angle and it's negative. What do we know about negative angles? If a negative angle of a side, if it's sine and a negative angle, the negative goes at the front of the sine, we end up with a positive angle. So let us go ahead and expand it then. It's going to be, write the whole expansion in a bracket. So it's going to be sine A cos B minus cos A sine B. So what is sine A? We don't have sine A. We have cos A and cos B. Cool. But we don't have sine A. What do we do now? Let us move this somewhere there, minimize it to the smallest. Let's not worry about that for now. And then they say it's between these angles. So in this situation, we see we expanded, but we don't have sine A. How do we solve for it? Remember I told you in the early stages that cost is going to be your best friend. 180 degree, 270 degree. So let's start with cos A. Wait, what do we want? We have cos A, we have cos B, but we don't have sine A and sine B. Okay, so let us start working with cos A to solve for sine A. So they say this angle is between 0 and 180, so it's somewhere here, somewhere at the top of the x line, right? Cos A is negative fraction 24 over 25. So when you get a fraction like this and the negative is here, immediately the top number is the negative for cos and sine, not for tan. For tan, it can be tricky. We'll get to 10 when we deal with 10 at certain instances. So what I'm saying here is we are given cos A is minus 24 over 25. But this negative goes to the numerator because we know that cos is x over r, right? R is always positive, is the hypotenuse. It's always positive. And so that's why we are assigning this negative to the top. X can be positive or negative, but R is always positive, or H, hypotenuse, if you're gonna write it as A over H. The hypotenuse is always positive. Please remember that, always plus, right? Now that we established it's always positive, the negative goes to the x, so it's negative 24. Negative 24 is gonna be somewhere here. So yeah, let's say it's negative 24. It's on the x line, right? And then we know that, so we just draw a line. Yes, so this r is 25, this side is 24, and this angle is over here. So this is like 180 degree minus angle. So it's like cos of this angle is negative 24 over 25 if we draw it with a triangle, right? Remember, you must know how to draw these triangles correctly or to your best convenience, and this is the way. So now we want to solve for this to be able to get sine A, right? So we need to solve for this. How are we going to solve for that? Pythagoras. So 25 squared is equal to y squared plus negative 24 squared. And when you solve that, let me just solve it right away. We all know Pythagoras. Hopefully we all do. Minus 24 squared, you're going to get 7. So this is 7. And so sine is going to be 7 over 25. So we got sine A, but we still don't have sine B. Wherever you are, if you want to write this, you can write it out. I'm going to erase it, but just know that we got, let me just write sine A over here. It's 7 over 25. So now let's quickly solve for sine beta. Cool. So with this one, now we're working here. says it's between 0 and 180 as well. Cos beta negative 7 over 25. Where does the 7 go to? At the 7, so it's going to be negative 7 here. The radius is going to be 25, 90 degree beta there, and the hypotenuse is 25. Same thing, Pythagoras, 25 squared is equal to y squared plus minus 7 squared. Solve for y is equal to 24 this time, so it's quite big. So sine beta is going to be opposite over hypotenuse. We just got y to be 24, so its opposite is 24 divided by 25. Okay, so now that we got that information, let me write it somewhere here. Now we can go ahead and finish the rest of the question. So I'm going to carry on over from here, just going to write it bigger now. So it's going to be negative, what is sine A? We just solved it to be 7 over 25. Cos B, we're given to minus 7 over 25 minus cos A, it was given negative 24 over 25. Sine B, we just solved it to be 24 over 25. Let's clear out the signs. So when you multiply this negative over here, you're just going to get 7 over 25 squared, negative, negative, positive. But when you multiply the negative over there, it's going to be negative again, 24 over 25 squared. Okay, so 7 squared over 25 squared minus 24 squared. Same denominator, right? And you know what? You can use a calculator here. Or you can use a calculator to expand everything out first. So 7 squared, 49 minus 24 squared, 576. So you must know when you need to use a calculator, right? And it's in this case because we're working with very big numbers. So 49 minus 576 minus 527 over 625. Can that be simplified further? Let's see on the calculator. No, it cannot be simplified further. So our final answer is this. I don't know if I made a numerical mistake somewhere, but you want to make sure you follow the logic of the question and you should be fine. Hopefully, if you've been following along and I made a mistake, hopefully you will pick it up. You really want to make sure that you follow the logic of the question and you know how to use your cost diagram with the given information to solve the rest of the unknown trig questions, trig angles, right?